guys. So keep solving our physics subject GRE. So 76. The hoop of mass is radius r at rest at top of indicated plane. Show a hoop rolls down. So hoops means that the mass is just in along the boundary. So the initial moment inertia is just mr squared. But it's large m, so large mr squared. So this is the hoop. And and ask about when the hoop reaches the bottom, the angular momentum. So I think once you know the v, then you know the angular momentum. So L just I omega. So the rest is we just find omega, and then this omega is v over r. So I plug m r v, right? So what we need to is just find the v. Okay, and so we just use the kinetic the energy conservation. What we have is the translational kinetic energy, and plus the I omega squared. This is rotation energy equals to the mgh. This should be large m. So we have this one plus this one, and by the way, omega squared is v squared over r squared. So this one is same as this term is same as this term, because r equals to mr squared and omega equals to v squared r squared. So it cancelled. So these two terms are actually the same. So you have mv squared equals to mgh. So v is equal to gh. V squared is gh. Okay, so now we know the answer because the answer is Rv. So Rm times square root gh. So which one is the answer? The answer is A. Simple. So 77 particle constraint moving an x in the net force. So simple harmonic oscillation, right? But not quantum mechanics. What we need is just the standard harmonic oscillation. And when x equals a over 2 and the particle speed O. So the total energy is when it reaches the maximum, then this one should be this one. So the total max velocity is the same as the total. When the kinetic energy go to the max, then it should the same as the total potential term. Okay, so this is the first term you need to remember. Okay, but now you say that the x is a over 2, right? So what it means is that so your v max is equals to okay, how about okay, let me solve it by this way. Okay, so when your x is a over 2, so this is your kinetic energy, and then what it plus the kinetic, and this is your potential plus the kinetic energy, which is this one. This one is the same as total kinetic and total energy, right? So plus the kinetic energy Ek should be this one. So what we know is that Ek is the 3 over 4 of this term. Okay, so what we know is that what we know is Ek. What we know is now our kinetic energy is this one, and then this equals to half mv max square. Not v max, our velocity square. Okay. Okay, what it tell you that is that if you compare these two equations, what you get is your V bar is just V max times 3 over 4. But since they're square, right? So your V bar square is V max square times 3 over 4. So that means you should have a square root here. Okay, and your V max, you can solve V max by solving this, right? So the V max just M over K square AK. So K over MA. So this is the answer. But you will say, oh, there's no this answer. But you say that, but you can see that you know that omega is K over M, and omega is 2 pi f. So basically, this term is 2 pi f a and 2 square roots. So it's pi f a square root of 3. Pi f a square root of 3. So the answer is B. The answer is B. Okay, so you just ask about energy conservation. So I think it's easy to solve it. Okay, so 78 the system. Oh, I should go to the original because I didn't catch the answer. Okay, so 68, the system consists of two charged particles with equal mass, initially far apart and have zero potential, and one of them non-zero speed. Okay, so basically asking, so the total energy is what? Is the kinetic energy. So it's positive. Total energy is kinetic energy plus potential, but now potential is zero. Potential is close to zero, and the kinetic energy is positive. So the total is positive. So which one is the correct? Basically, total energy need to conserve. So the answer is C. It's positive and constant. The answer is C. That's it. Nothing special. Okay, so I think it's enough for today, and I will see you guys in next time. And be sure to subscribe to my channel. I will see you guys in the next video.